Hey guys, welcome to another episode of CUDA Education. I just wanted to do a quick follow-up on the barycentric coordinates stuff. So this will be, for now, my last video on barycentric coordinates, but I wanted to follow up with some more information. So in the previous video, we went in depth about barycentric coordinates and what it's for. It's the weights that, help us to figure out whether we hit a specific triangle or not. So the weights, tell us, are we hitting the plane of the triangle, or are we outside of the plane of the triangle? If we're outside of the plane of the triangle, it's not a hit. But if we do hit based on the weights, then it's a hit, right? We discussed that in the previous video. Here, I just wanted to quickly go over. So this is the hit shader. So I'm in the hit shader in the ray tracing position fetch algorithm. I'm in the hit shader, and what I wanted to highlight was this right here, right? hitAttributeEXT vec2 attribs, okay? So this variable is actually the weights passed into us by the GPU. So the GPU gives us access to these weights because, it gives us access to these weights. Now, it is because the reason why it gives us these weights is because, so the reason why we have access to these weights in the attributes variable is because in the actual source code, we have this VK geometry type triangles KHR. This VK geometry type triangles KHR, it means that the intersection, the hardware intersector is active, okay? So this flag was put up, geometry type VK, geometry type triangles KHR. It was part of the bottom level acceleration structure. And guys, we know the bottom level acceleration structure is always the geometry, the vertices of the objects that we are using in our application. So the bottom level acceleration structure, create the bottom level acceleration structure containing the scene's actual geometry. So we know that the geometry all comes from the bottom level acceleration structure. Now, if you're talking about multiple instances of, for example, the triangle, multiple instances of whatever object we created with the bottom level acceleration structure, then we're talking about the top level acceleration structure. But we're not worried about that right now. We're focusing on the bottom level acceleration structure. So we'll see that because this VK geometry type triangles KHR flag has been used, we now have access to the barycentric weights of the intersection point. Remember, this is the intersection shader. So this is just our straight CPU side, the code, all the things that we're typing out, the instructions. This is on the GPU now. This is the shader stuff, okay? This is a shader on the GPU. So we have this attributes variable that actually gives us the weights that we discussed in the previous video, right? So these are the weights now relative to the vertex positions of the triangle. Again, we don't necessarily know the vertex positions of the triangles unless we take advantage of the ray tracing position fetch extension, but that's a different discussion. We get the weights with this attributes variable, and we can see that we need the barycentric coordinates to calculate data for the current position. So notice that we have attributes.x and attributes.y. Now notice that in our example, we had x weight, we had y weight, and we had z weight. But notice that this variable is vec2. And the reason it's vec2 is, again, relying on one of our rules. All three weights have to add up to 1. So we know what x is, we know what y is, and we have an unknown z. But we could calculate z we just take the number 1 minus the weight for X and minus the weight for Y, and then we'll get our Z value. So this is the Z value, this is the X value, and this is the Y value. Remember in mathematics, guys, you can only have one unknown, and you try and solve for that one unknown. So we have our X and we have our Y, and we could solve for our Z. Don't ask me why the powers that be made it this way, but this hitAttributeEXT is what allows us to get the barycentric coordinates into our shader, and then we could calculate stuff and do stuff with it. Again, remember, if you want the vertices of the triangle, it's these guys here, right? So this attributes is the barycentric coordinates, right? Barycentric coordinates, X, Y, and then we calculate Z. This is the barycentric coordinates. This is the the vertices of the triangle. X, position 1, 2, and 3, right? So vertices of the triangle, barycentric coordinates, right? And then, we do stuff with it. But it's now accessible and passed into the shader, all right? I just wanted to add this because it's an important piece of the conversation that I did not include in the previous video. So this is my second video on barycentric coordinates. I believe it's a ray tracing 14 series, right? So 14.0 I think was the previous video. This is 14. This is going to be 14.1. All right. Again, guys, if you want to be able to run this stuff, do this stuff, follow along. Get tutorial number 1 and get tutorial number 13. I assume that you have a Windows-based machine with a Vulkan-capable GPU that is also ray tracing capable. So for NVIDIA, that means RTX cards and greater or later and greater. I don't know about Intel and AMD, but if you want to be able to run these examples, to run Vulkan, you need a Vulkan-capable GPU. That's tutorial number 1. And then tutorial number 13 is to install all of these examples. Just know that if you want to run the ray tracing stuff, you need to make sure you have a ray tracing capable GPU. Not every GPU is ray tracing capable. All right. For NVIDIA, again, it's a RTX series and whatever later and greater that you have in the future. All right, guys. Thank you for watching. This is CUDA Education. Have a great day.